Welcome back everyone. As we are studying the operations of the lathe machine, we have studied already that 4 operations: facing, turning, knurling and threading we have studied. The next operation is tapering. Before going for that, how that operations will be taken, the tapering operation will be taken. What do you mean by the taper? Taper section means what? That has to study. To study that taper, you know, this is a cylindrical object. Means what? Along this length, diameter is same. Both the side that the diameter is same here. This is called as a cylindrical object. The operations on this are totally different here now. So next one, if I take such one here now, such one, here you see this object here now. Here that the diameter is small, here that the diameter is more here now. This is a slope. Slope is there here now. This is a slope is there here now. If we want to make a object from the cylinder to taper, we have to remove some certain material to maintain this slope. This is a original diameter. This is the last diameter here now. This amount of the material has to remove with respect to the slope, maintaining the slope here now. So therefore, the tapering is very important that operations. Certain attachments has to be made in case of the lathe machines here now. So therefore, just we will study some nomenclatures in case of the tapering. Tapering section, how it will be looks like here now diagrammatically. This is a taper section here. For example, this is the taper section here. This is the axis of the taper here. Right. So original diameter from this object, this is a main object here. This is a main object here. So originally this one is this much here. So originally this object is this much here. No, correct. This is this much here. This much amount of material has to be removed. So therefore, at the last we will get that much of the diameter here now. That is D2 here now. Small diameter we are getting here now. Original diameter is this one. This is the here we write it here now. It is a D1 here now. So continuously this slope is there here. This is a slope is there. This slope has to be maintained continuously. This much amount of the material has to be removed here now, like this. So see here. Now we are getting this section. It is called as the conical section here. This is called as a conical section. So next, so this length here now, the taper length, it is there. This is taken as the L here now, and original diameter is D1, and that last end diameter here now, here it is the D2 here now. So therefore, here another one parameter will comes, that is called as the conicity here. That is called as the conicity here. That conicity means what? Conicity means it is a D1 minus D2. Means what? The original diameter minus that is a end diameter after removing the material here, divided by length to which that slope has to be maintained. Taper section has to be maintained. Decreasing area. Cross sectional area is more here, and it is decreasing in this direction here. That's the last we are getting here. So then it is called as the conicity. It is represented by K here. This is called as a conicity here. So next one, if we are extend this the line here, line of this object here, somewhere these two will meet at a point here now. So these will make with this axis angle here now. Here it will make alpha. Here also it will make alpha here now. So therefore 2 alpha is called as the taper angle here now. It is called as the taper angle here now. And simple, only alpha is there, semi-taper angle. Semi-taper angle here now. This is called as the semi-taper that angle here now. So therefore, the next is, this is about that taper section means what and conicity and all here now. Then how to find out this the taper angle alpha here now. Alpha can be find out here now. It is alpha is equal to tan inverse of here D1 minus D2 divided by L here. So D1 minus D2 divided by L is what? It is the conicity here now. So therefore semi-taper angle alpha is equal to tan inverse of K here. tan inverse of k. That is the conicity here in this case. So this is about the conicity means what, semi-taper angle means what, how to find out semi-taper angle by mathematically how we can find out, and tapering means what we have studied. The next one is what here now, how to make it operations here now. There are two operations we can make on the lathe machine here to find out that taper sections, means to make the taper sections on the cylindrical object here now. So first one I will take here now, that is the tool post offset method. Tail stock offset method. First one I will take here now, tail stock offset method. Tail stock offset method here. What is tail stock offset method means what here now? Here one thing we have to study. One is a live center which is attached to the head stock, because there will be the moment in place of the chuck. In place of the chuck, we are taking a live center here. So this is that live center here. So for example, this is the live center here. This is rotating here. This is called as the live center here. This is a live center and it is rotating. And it is rotating here now. So next one, the another one is dead center. Another one is dead center, which is attached to the tail stock of the lathe machine, but it is not rotating, but it will give support to the object, our workpiece here in this case. So next one, how we are making this one now? See here, we are fitting one side. Right. So see. Like this. So this is the total length here, this one. Here total length here L1, and length here made it here now, it is a L2 here now. For the taper section it is a L2 here now. D1 is the original diameter, D2 is the final diameter here now. Final diameter here now. Here is the tail stock is come into the picture here now. This is the tail stock here now. This is actually tail stock. This is called as the dead center. Why it is dead center? It is not the rotated by the engines or some motors here, but it will give the support to that object here in this case here. So next, how to find out? This is the offset. What is the offset here now? Offset means if I take this is the center of this live center here, the center line of this dead center here now. This is called as the offset here, x, where x is the offset here now. X is the offset means how much that the dead center which is fitted in the tailstock has been offsetted. It is moved and fitted here now. So that arrangement has to be made. That method is called as the tailstock offset method here now. That how much distance it is offsetted here now? X here. That x can be found out by that offset. That x can be found out here in this case by it is d1 minus it is a d2 divided by 2 into it is L1 divided by L2. This is the formula by which that means we can find out here that how much we can offset here now. L1 is the total length, L2 is the taper length here now, and next one is D1 is the original diameter and D2 is the final diameter here in this case. So therefore x we can calculate here now. Then accordingly we have to offset this dead center and fitted in the tailstock. then fit between the live center and dead center, that workpiece here, and this tool is there. This is the tool here. This is the feed will be given in this direction here, no, feed. In this direction, feed will be given here. This is a tool here. This is a tool, the axis is there. It is perpendicular to the axis of this dead center or a live center here in this case. This is a method is called as the tapering tailstock. Tapering by the tailstock offset method. Offset is x. X can be found out by this method here. So next one, that is operation is called as the compound swivel. That is called as the compound swivel here now. That is called as the compound swivel method here. That is called as the compound swivel method here. What is that compound swivel method? As we have studied in case of the parts of the lathe machine, there will be the one part that bottom of the tool post, that is called as the compound slide. Compound slide means that compound slide can be swivel like this with some angle here now. With some angle we can swivel it here now. So therefore, so how much we have to swivel in case of the compound swivel method here in this case. So definitely that the headstock here. So in this headstock there will be the live center here in this in this headstock. There will be the chuck here. In this chuck definitely there will be the metal, the cylindrical object on which we have to make that taper that has to be set at here in this case here. So that is there here. And the next one is how much has to swivel. This is the axis here, axis. Then from this axis here we will make another one axis. This angle will be alpha here. It is what here, alpha is what? Semi-taper angle here. Alpha is equal to tan inverse of here d1 minus d2 divided by L here now. It is a semi-taper angle. Semi-taper angle. So what we are doing here now, we are setting a compound slide. Compound slide is there. It is swiveled with angle alpha with respect to the axis of this axis of this live center, or else it is a headstock axis here. So next one, so this is that the feed wheel here now. This is a feed wheel that how we can operate it here now. So therefore it can move here now. So here just I will make it here now. So next one here that some graduations are there made here no? Some tool is fitted on this here by the nuts. By the nuts are there here. By the nuts that tool is fitted here now. So like this. This is a taper operation here. This is a tool here. Tool will be fitted here now. By the nuts are there. Here the nuts are there. This is a tool here. Tool. This is a workpiece or a job here. This is a taper section here in this case. And it is fitted with another one. It is a dead center here now. It is a dead center. It is the chuck here now. It is a headstock, and it is a chuck here in this case here. This is axis here in this case. So now it is some graduations are they made here. Some angles, angle graduations are made. Yes. How it is taking place here? First, the workpiece has to be setted in the compound swivel. Then afterwards, it is fitted between the dead center and that is a chuck here now. Then what we are doing? This compound slide is there. We are shifted with the angle alpha, which is found by this formula. Then we are getting the feed here now, like this. then taper operation will be done on the cylindrical object here. This is about the tapering operation by the compound swivel method here now. This is the second method here now. So angle alpha is taken here now. There are two methods to make a taper. One is a compound swivel method and another one is a tailstock offset method here. So therefore it is about tapering. In the next video lecture we will see some another one operation, how to make it drill and specifications of the lathe machine here. Thank you very much.